Hello everyone, we will solve this today's LeetCode problem. This is LeetCode medium. Let's see what it is. So here it is given kth smallest prime fraction. So you are given a sorted integer array containing 1 and prime numbers where all the integers of array are unique. You are also given an integer k for every ij where 0 is less than I and less than j dot array dot length. We consider the fraction array I by array j. Return the kth smallest fraction considered. Return your answer as an array of integers of size 2, where answer 0 is array I and answer is array j. Okay. So we have given an array of prime numbers only. So 1, 2, 3, 5 are all primes, and we have given a k value, and we need to return the kth smallest prime fraction, which will be made up of by any combinations of any two numbers of array. Right. Okay. Okay, so in this question, we need to find the kth smallest fraction, right? So for finding the kth smallest fraction, so if we see the time constants here, here it is given array dot length is 10 to the power 3, array I 10 to the power 4, array 0 should be 1, and array is a prime number, and all array numbers are unique and sorted in strictly increasing order, and array dot length, okay. Okay. So we have given 10 to the power 3 only this array dot length. So it means O of n square will also work here, right? Will also work here, right? So one thing is here that this O of n square will also work here, right? So so 10 to the power 3 means 10 to the power 6, and so of O of n square log n will also work here. So okay, okay. So this will also work here, right? Okay. So O of n square of log n when squared, yeah, right. So this will also work here, right? So of n log square, this will also work here. So one thing is sure that by seeing the constants, that I can use the brute force approach here because the constants are very less, right? So I can use a brute force approach here to find all the combinations of all the pairs of the fractions, and short it, and simply return the third, the smallest prime fraction. Oh, right. Yeah, simply I can do this, right? So if we see the brute force approach here, if we see brute force approach, brute force approach. So what we can do is, what we can do, we can find, we can we can make every possible combinations of two elements of an array, of this array, right? Also we need to consider this as a condition that this j should be always be greater than I, so then I can find this array I by array j. It means this array I by array j will always be between this 1 and this 0, right? Right, so it will be greater than 0 but less than equals to 1, right? So this will be always correct because array j always be greater than array I, because it is given that j is greater than and it is increasing order, right? So this condition should also true, right? So we will need to find every combination of elements and array, and then we will simply, and then simply short it according to the fraction values, and then return the two pairs, and return the kth smallest prime fraction, smallest prime fraction numbers. So we need to return 2 5 here. So if we see 1 2 3 5, so 1 5 1 3 and 2 5 is here. So if you find decimals of all this, so the third smallest will be 2 by 5, right? So this is how we need to short it, and we can do this in and return the kth smallest prime fraction, right? So this will be this will be a valid solution because the constants are very less here. So for making every possible combination, it will take O of n square, and by sorting it, it means all the o of n square values can be an answer, and that will be sorted. So that will be o of log of n square, so that will be o of n square log of n square, right? That will be the time complexity, which is 10 to the power 6, and log of n square is 6 into something like, yeah, 6 and 6 log is 10 to the power 6, right? 6 log 10. So that will be of n square, that will be of n square and log n square, right? So this will be an approach. This can maybe one of the approach, recursive approach. So let's see how will we implement this. So for making all the combinations, I need to store. Okay, at last, I need to return this in elements, which the elements will be the. So I need to also store in this. So for that, I can take it as a pair also, right? I can take it as a pair for storing this fraction, because this fraction will be in decimal, so I will store double, and I will take this an integer. So this is how we will store this, and I will store this in a vector, right? So this is 1 2 3 and 1 2 3, right? So now what I will do, I will start iterating from first part, and we will start iterating in second loop, which will be always I plus 1, because this j is greater than I, right? So this will be less than n. Okay, this I and j will never be equal, so this will not be equals to 1. It will be always less than 1, so it will be only greater than 0 and less than 1, right? So for that, I need to push back. I need to push back this I, and this j is both an integer given, right? But if I store this as an integer, this will give me this will not give me a, s- a valid answer. So I need to store it in double, which will be which I need to also um, typecast this. I need to typecast this because this will give me an integer. So I need to make it doubles. For that, I need to typecast this to double, so that it will give me a double value, and so that we can compare it, right? So first we will store this value, then this indices I and this j, which gives me this value, right? Because ultimately I need to return the values here, right? So I will return this. Now ultimately I have all the values in my vector. Now I will sort it. I will simply sort it. So when we do sorting, it will if we don't give any comparator functions that how we will want to sort, then it will always sort according to the first value, which will be in the first value, right? The first value it will get, it will sort according to that, right? So, and now what we need to do, we need to find the kth smallest fraction. So the kth smallest fraction is here it is given from 1 to 3, but in this we have index value from 0. So I need to return b k minus 1th dot. Now what will we return? We need to return the vector, which is this 2 and 5. So I need to return this in vector. So the first value will be this first, and this is second dot first, and this is second dot second. So this is the first index, and this is the second index, and this will be the array value which will be inside this, right? So I need to make this in this side, this, right? Array. So this is seems to be complex, but if you break this, so what I can do is should be the first. So is the first index. This is the first index, because this is double pair, right? So this second pair denotes this whole pair, and second dot first will return the first index. So this is the first index, and this is the second, which is second dot second, right? So instead of this, we can return first, and this can return second. So, and we will simply return this answer as an answer, right? So let's try to run this. Let's see. So we have successfully passed the sample case. Let's submit it. Okay, we have successfully passed the test case, but passes this solution. But this is O of n is square. But what if the length of this array is very very greater than, right? So this is an optimal. This is not an optimal approach. This is a brute force approach. So if we think of any other approach so that we can less than this, of course, O of n square, less than this O of n square. So one thing we think of this approach, that don't you think that we have all you have already solved this approach? So if you have solved the top k frequent word problem, right, or something like uh, the kth kth sorted elements, the kth sorted linked list problem, or something like this. So if you have solved this type of problems, that you need to return the top k frequent words problem, or top k frequent word, or top max k the kth elements, or minimum kth maximum elements type questions. So you think of approach of as a heap approach, which is a priority queue, right? Which is a priority queue approach. So can you can we solve this using a heap? Let's see. So what we are doing here, we are inserting all the fractions and sorting it ultimately. So that's why it's taken of n square. But instead of doing this, if we see here, this is already sorted out, right? So this 1 by 5, and this 2 by 5, then 3 by 5, sorry, 3 by 5, 4 by 5 by 5, not 5 by 5, because it should be less than. So if we see this 5 will, this for this one, for this one we are, this can be the approach, right? So for 2, it, it should be like this also. For 2, this 3 by 5, sorry, for 2 this will be 2 by 3, 2 by 5, right? uh, for this 1 by 2, 2 by 1 by 3, 1 by 5. So this and this can all be the fractions possible. So 1 by 5, we are for sure that this 1 by 5 will be less than this 2 by 5 will be less than this 3 by 5, right? But how we will compare this 1 by 3 to 2 by 3, and 1 by 2 with this 2 by 3, right? So we can compare if the denominator is same in this case, then we can compare with the numerator, that this 1 by 5 is less than 2 by 5, this less than 3 by 5. But if numerator and denominator is not same, then how we will compare, uh, the both of the fractions? So so one thing is here, we can you can see that if I insert all the fractions of, with taking the maximum elements like 2 by 5, 3 by 5, uh, 3 by 5 in my answers, right? And after that, suppose I need to I've inserted this in my priority queue, right? So if it gives me some values, right, so I need to find the kth element, and that I need to find the kth smallest element. So for that, if I start taking the max heap, suppose I have taken the max heap, suppose I have taken the max heap, and I've inserted all the first iteration by dividing it by maximum elements which is in my array, right? So if I take the max heap, so what will the max heap here? So it will give me 3 by 5. The top elements will be 3 by 5. The top element of heap will be 3 by 5, right? And we need to find the kth smallest, which is 3. So the top element will be 3 by 5. So there are also possible that 2 by 5 and 2 by 3 will be, can be this third element, right? Can be this third element. So for that, if I started popping it out from the top, this 3 by 5, and start decrementing it. So when I start decrementing it with 3 by 4, So it will insert it get into this, right? It will get inserted into this, because ultimately it is, need to return the third smallest. So if I suppose I have, instead of this fraction, let's suppose this is given 1 2 3 4 5, right? Instead of this uh, fractions, let's suppose this is given 1 3 4 5, and we need to find the third minimum element in this array, right? So how will we can do this with priority queue? So if I started storing in max heap, so what, suppose this is in not in order, this suppose 4 5 1 3 2, right? So if I started from 4, so I will insert this 4, then I inserted 5, then inserted 1, right? Now I need only this third minimum element, means k is equals to 3. So if I when I start pushing it in 3, so it has the length of 4, right? Which is greater than 3, and we need only the third element. So if I pop this out, if I pop if I pop the top element, so what will it be? It will be give me 5. This 5 will pop out, this 5 will pop out. Now what will left? 4 1 3, right? And now we will insert this 2. This 2 will insert it. Now this is again greater than 3, so we will pop this out. Again the top element will be 4, because this is a max heap. So 4 will pop out, 4 will pop out. So now what will be left? 1 3 2. So now this has left with 3 elements only, and we also only need third element, minimum element. So the third minimum element in this will be the maximum element, don't you think? The third element will be the maximum element, because we have already removed all the maximum elements which is greater than this, the third minimum element, right? So the top element will be the answer ultimately, right? Answer, the final answer will be the top element, which is equals to 3. And you can see this, the third element is answer of which is 3, right? So if you have observed this here, if you have observed, for finding for finding the kth smallest element smallest element from array, I take maxip and remove all the top elements, which is when the length of when the size of heap is greater than greater than the kth element, kth, right? And the top element will be my answer, will be my answer. Why it is happening? Because this the number which is greater than the kth smallest number is already removed in the max heap. So the left out number will be the left out number in the priority queue will be the top element, which is will be the kth smallest element. That's why we are taking max heap for the kth smallest number. So this vice versa will always also be true, right? Why? So if we want to find the kth largest element from array, then what I need to take? I need to take a mean heap. Then I need to take a mean heap, and the procedure will be the same. That whenever the size is greater than the kth, the top element will be the answer. So we will remove that, and the top element. So when the size is greater than k, we will remove all the top elements, and the top element, ultimately the top element will be the answer, right? So this vice versa will also be true. So same approach will be applied. The same approach will be applied to this fraction value also, right? The same approach will be applied to this fraction value also. In this, we are storing all the first elements by dividing this 1 by 5 and this 2 by 5, 3 by 5. And after that, whenever I pop this top elements, so I will decrease this denominator, so that it will give me a some maximum value, which will be again rearranged with itself and give me one of the top elements, so that I can pop this out, right? So the same approach will be applied to here, right? Same approach will be applied to here. So what I need to do, same approach will be applied to here, right? So same approach will be applied to here. So what we are doing, we are inserting all the max elements, all the mean elements, right? We are inserting all the mean elements from this 2 by 5, then 3 by 5 in my priority queue, right? So this will give me the smallest prime fraction. So we will insert this in maxif, right? We will insert this O of n, all O of n will be in my maxif, and then what we will do, we will start decrementing this k along with this, and what we'll do, we will start iterating in heap, pop the top element, and insert what we will insert, we will insert by this current first element, this that is 1 by 4, right? Why I'm decrementing this 5 value? Because if we don't decrement this, then we will not able to, sorry, this will not be 4, this will be 3, because the elements which are here is 1 2 3 5. So if we not decrement this, we will not able to find all the possible possibilities that will be give me the kth value. So I need to also decrement this, because this 1 2 3 will ultimately come, but in this denomination this 3 will not come if I don't decrement this, right? The index value. So this 1 by 3, so again we will pop the top element, and so the first element will be the 3, because uh, the first element will be the 3, because in this the top element we are storing in maxib, the top elements will be 3 by 5 here, right? So we will insert we will the top element will be the 3, right? I think so. I also need to insert this this by decrementing this 5, I will go to this 3 value, then I need to insert this 3 by 3, but this 3 by 3 is similar, because similar indexes which is not equal, which is not given in my answer. So I need to check that whether this the second index and the first index of the fraction should not be same. So we will not insert this, we will insert this uh, 2 by 3. We can insert this 2 by 3, then we can insert this in 1 by 3, right? So we can insert the whole 2 by 3 1 by 3 like that. So this is how we can do this, that pop the top element, decrease the denominator, and sorry, so uh, and decrease the top denominator, and if the indexes are not same, then we can insert this in my priority queue, right? And we will do till when, till my k not becomes, till not will k will not become 0, till k will not become 0, right? And the top elements will be the answer. Top element will be the answer, right? So this is how we will do this. It's the same approach which we have seen in this. This is here integer and this is here fraction. So let's see how we can do this. So instead of taking this, we can use a priority queue. So okay, if you don't understand this, then you can do this take this example, take this any example, and do it on pen and paper. You will ultimately understand this. You will finally understand this. So what we are doing, see, we are just popping out the top element, decreasing the denominator. So if I write this here, we are popping out the top element and then decreasing the denominator by one index, and if the index of denominator and nominator, top elements and fraction is not same, then we will insert this, then we will insert in my priority queue, right? So this is how we will do this. And why we are inserting this, because we are decreasing this denominator and inserting it, because it can be possible that it will give me a maximum, it will give me a more than the value which is uh, this 3 by 5. So if you compare this 3 by 5 sorry 2 by 5 to 2 by 3, which is largest? 2 by 3 is largest, right? So it can be possible that this kth smallest element will be 2 by 3, not 2 by 5, right? So this should be the check uh, accordingly with this, that, right? So that's why we need to do that. So we will use a priority key here. So in priority queue, what we will start making a mean heap. So in priority queue, we need to take a pair, right? The same pair which we make here. So just we need to copy it, and we need to make a mean heap. So this is how we will make a mean heap. So what we will do, we will first insert all the elements in it, but just of the starting point from here, and this is how we can do that. So the value will be same. Instead of j, this we will take only the n minus one value, and this I and j should not be equals to it should not be equal. So I will iterate only till n minus two and divide it by I n minus one, and we will just change this j to n minus one. And for this, I need to insert this in priority queue. So that for that, pq dot push value I minus one minus one. Now we will remove this short function. Now what I will need to do, we will need to iterate in this k, right? And we will pop this out. So we will what we need to do, we will take the top element and we will remove this. Okay, let's not remove now. We will find this the top element. So the first pair is value and second is pair itself. So the x dot second will be the pair index, right? And the first will be the nominator index, the nominator index, and the second will be the denominator index, right? So this will be the first will be the denominator and the second with the denominator index. Now what we need to do, we will check, we will need to decrement this denominator so that the next element which will be inserted will be greater than the previous elements, right? So we need to check first that this nomination index should not be equals to the denomination index, and then only we will insert in my answer, right? So we will just do the same thing here. Just push this here. So instead of I, there will be nomination index, and n minus one there will be denomination index, and the same thing will goes to here, the nomination index and the denomination index. Will push it. And lastly, what we need to do, we will need to pop this out this PQ okay. You can pop this before also, because after, if you insert this and then pop out, so it is possible that this will get pop out first before this, right? So just pop this out. Just pop this out. Just pop this out. PQ dot pop here, right? And then what we need to do, we also need to decrement this kth value. So that will be k minus minus. Okay. So at which point we will need to remove come out also out of this while loop. So kth is at 1 to 3 index, and uh, we are at what higher, so 3 to 1, right? So when we are at k is equals to 1, so we need to break this up, right? When we are at k is equals to 1, we need to break this. So, and after breakup, the top element will be the our answer. So instead of this vk minus 1, what I need to write, vk dot top dot second. This should be the top elements, and its first index will be domination, and this is denomination. Okay, so what we are doing, we are inserting all the elements by taking the fraction of the maximum elements, that 1 by 5, 2 by 5, 3 by 5. Then we are popping out the top element, which will be the minimum elements of this, due to this heap. So what will the return? 1 by 5 will be returned, because 1 by 5, 2 by 5, and 3 by 5. If we write here in 1 by 5, 2 by 5, 3 by 5, what will the minimum elements? 1 by 5 will be the minimum element. So it will pop out, it will pop up, right? So let's see the first the sample case. Uh, okay, this should be removed. Then we will understand how this is working. Let's run the sample case. Yeah, this is working, right? So just 1 by 5 I will pop out, and we are decreasing this denominator to make it the upper part, means the larger than this value. So it will becomes 1 by 3 now, because this 5 will 5 index will get denomination to 3. So this will become 1 by 3. Now this 1 by 3 will be inserted, because this both are not at the same index. So the next element which will pop out will be the, again the lowest element, which is 1 by 3 or 2 by 5, right? Again the 2 by 5 or 1 by 3. So which is the smallest? So 1 by 3 is the smallest, so this will be pop out. So again 1 by 3 will pop out, and now the 1 by 2 will be inserted. So 1 by 2 and 2 by 5, which is the smallest? 1 by 2, but 3 by 2 by 5 is the smallest. Yeah, 2 by 5 is the smallest, but till then k has already becomes 1. If you see, this 3, this 2, and after this the k is already becomes 1 here. So when k becomes 1, we will just pop out, and this 2 by 5 will be the answer here, right? So just try pen and paper out, and you will be well good to go with this. So this is how we will solve the problems 1 by 5 and 1 by 3, right? So let's submit it. I know this is some bit confusing by analyzing in the fraction, right? Yeah, we have passed the test case. It is some bit confusing if we analyze in using fraction, but if you observe carefully, so we are just pushing it in mean heap and popping it out and inserting it again by decrementing the denominator. This is the how we will solve this, right? So, and the time complexity and the space complexity will be, so what we are doing, the time complexity will be, uh, the first thing which we are doing is inserting all the n elements in a priority queue. So that will take O of n log n, of course, right? The second thing which we are doing is, we are popping out the top element and then inserting it again till k times, right? So that will be taken as k times log of n. So that will be ultimately O of k, sorry, n plus k log of n. And the space complexity will be, so we are taking an extra space of priority queue, so that will be O of n. So because the popping and inserting is simultaneously, so always be O of n space complexity. So this is how we will solve this problem. I'm sure it can also be it can also be solved with it can also be solved with binary search, but video is already being very long, so I think this binary search, you should think of this approach. Although although uh, uh, heap is the heap is heap is the optimal approach than this, or heap is a better approach than binary search. Heap should be the better approach than binary search, but you should think of binary search. How will you apply this in binary search, right? So yeah, thank you. Bye bye.